Welcome to Kubernetes in Action Exercise 4. So here what I'm going to do is, as per the last video I have said that I'm going to do monitoring few pods using C advisors for health and errors, and next then I will do benchmarking load performance using bench test. So uh, um, first I am going to do this benchmarking using load test, then we are going to see that C advisor, because that will be more meaningful, because that whenever I am raising a request, then you can see the C advisor spikes in throughputs and errors. Okay, let's see that how things can do in action. Okay, so for first I will introduce what is the tool called bench test. So I'm opening that. It is actually console level console interface load testing tool. So for that, so you need to install as a Node.js, because it's powered by Node.js. So I'm going to explain how to do that. First I'm changing to power user, it's called root. Then if you want to install the bench test tool in your machine, first you have to install the Node.js in your environment, and then you have to call the npm install -g then bench test. So what it will do, it will install the bench test tools in your machine. Then you can easily call the bench test from the command line. So now I am going to do the load test. So load test using bench rest tool. So for that I need that URL of this address. So let's see, let's check this something like which is very decent request. So I'm going to call that bench test using a five addresses per, which is limit. So 5 is the limit of the result set, and this is a postal code, and this is the address API, and this is hosted. So just check it whether it is working or not. Yes, it's working. So copy this address, because I want to do this bench test using this one. So bench hyphen rest, then I put the URL of this one. Then I am putting n. What is the hyphen n? N is the number of iterations. Okay, hyphen n is the number of iterations. That means it's equal to request. So how many iterations it needs to give that. Then I am going to put that concurrency for the iteration. So I am going to put, say, 100 users doing the 1000 iterations and using a bench test. So now I am going to check if I rest. So first we will go to the minimal range. So I will go to this 10 100 request concurrency of 10. Let's see how it's performing this address. It is excellent. So all the 100 requests are done in a second. So now I will do the same thing for same 100 request. I will do that 50 as a concurrency. So you will do enormous fast. See that, because everyone is sitting at the same time. And is also, so how it is scaling, see that in action. Right? So I am going to raise a 1000 request with 100 concurrency. Still this is so much fast. That's it. Okay, so 1000 request, 100 concurrency. Excellent, scaling nicely. Ten 10,000 requests with the concurrency of 500. See, still there is no 10,000 requests with the concurrency of 500. 500 users are hitting in 10,000 iterations. See, still there is no errors are hitting it, and we are getting nicely a histogram from this tool. So using this histogram, you can create that graphical interfaces. So you can store this output into that file, and then you can fetch into that. You can show in that any other web UI. And again, I'm going little for 1000 request with the 10,000 1000 concurrency with 1000. It's a very huge number for fetching this, because every calls is hitting that MongoDB and fetching the data and sending back to the user. You can see that per second it is going 500, 591. It is very huge in concurrency. So the system is thinking, because the huge load is in that place, but I thought it will be error, but still there is no errors, so it is able to finish without any errors. So let's see another thing. So I will put it 50,000 50,000 request in 1000 concurrency. So there is a huge data is flowing between that endpoints. It is very huge, and it is shared by 6 minions and 25 containers as of now. Still it is scaling very nicely, and then we are able to get the response back without any error. But I am expecting some errors because it's huge load. Let's see whether it can scale well in this manner. Still there is no error. I hope there will be error. That's what that it's not showing any status. Let's see whether still that it will be able to handle the load. And also that the 50,000 request is going in within a span of within 30 seconds. So it is huge load. Oh, so as per the expectations that the call is errored out. So these are the errors which is coming, the timeout error is coming. So that means that if you want to scale 50,000 without any error, so there are errors 400 out of 50,000 calls, there are 401 calls are getting failed. So that this is the symptoms that how that how this is symptoms how much you can scale. So instead of 25 you might require to go 50 or 100, that is up to that. So this will show us the apex point which the clusters will stand in. It may be the reasons because of the node, the MongoDB cannot handle the load, or your minions cannot handle the load. So it's up to that. So it's based on the experiment you have to do. You have to find your numbers and the containers load, everything you have to verify it. So now, with this demo, so I'm going to do that. So I'm going to show this how the health can be monitored with using cAdvisor in the next video. Because so now you understand how to scale, how to do the benchmarking. So once how that is it really it's doing that, really it is calling that our containers and all, I'm going to show with the cAdvisor, and then I'm going to show that how that CPU and memory is raising up according to the CPU the benchmark calls. Okay, let's see. So I will explain all the details how to monitor the health while doing load and everything in a real-time manner using cAdvisor next video. Thank you for the kind attention. Have a great day.